Let's look now at loops. So there are many situations in which I'm writing a program that I have to repeat some process. And whenever I need to repeat a process, then I'm probably going to use a loop. So in Python, there's two loop constructs, the while loop and the for loop. In both cases, they'll repeat the task as long as some condition is true. Now, I will say that the for loop probably gets used more often, but I think the while loop makes it more clear how loops actually work. So we'll start with that. So the basic syntax is this: the keyword while, some condition that should evaluate as true or false, and if it's true, then I'm going to do something. Now you may notice the syntax here looks very similar to an if statement. And if you've seen my video on if statements or conditionals, you'd recognize it as looking something like, if some condition is true, do something. That part is the same, that you're going to test immediately, and if it's true, enter into the body of either the conditional or the loop. Where they differ, though, is that once I've processed what's in the body of the loop, in the case of a loop, we come back up and test again. So that's where the repetition comes from. As long as this condition is true, we're going to keep cycling through doing what the loop says to do, retesting. And only when it eventually fails will we then skip past the while loop to what's below it. Also, just like with an if statement, it is possible that the test could be false immediately, and then we don't do anything in the body of the loop. So let's say I want to sum the positive integers starting at 1, as long as that sum is less than or equal to 100. So that is, I want 1 plus 2 plus 3 plus 4. That would give me 10, and so forth, as long as the overall sum is less than or equal to 100. If I did by hand, these would be the values I would get. So here's the integers, and I made it up to 14 before I finally broke 100. But you see here I have, when I only have 1, the sum is 1. Then I add 2 to that to get 3, add 3 to that to get 6, add 4 to that to get 10, and so forth. When the sum is at 91, because I made it up to 13, then I add 14 to 91, and that gives me 105. So my loop would need to stop at this point. Here's my code for doing that, as well as the flowchart that represents that. Let's look at the flowchart though first and see how it works. So I need a summing variable, as well as I need a variable of the integers I want to use for the sum. So I need something that gives me the 1, that gives me the 2, that gives me the 3, all the way up to the 14. So I come down here, I'm going to test, after I've created the two variables, if the sum is less than or equal to 100, then I enter the body of the loop. So I add the current value of I to my sum, print the current value of I and the current value of sum, and then increment I by 1 in this case, and come up and test again, and repeat. And eventually, when my sum reached 105, because I had been 14 at that point, well then I'll have sum is no longer less than or equal to 100, so I skip out of the loop and come down to here, where in this case there's nothing else to do. So here's the code that created the table we just saw on this page, including this print statement. And so initialize my two variables, while my sum is less than or equal to 100, colon, I need the colon, and then because these lines are all indented right here, they're all part of the body of the loop. Had I had a statement that started right here, it would not be part of the loop, right? That was one way that we use a loop, but there are many situations in which I want a loop to run a predetermined number of times. In this example, I didn't know how many times it would take to get to a sum that exceeded 100. I didn't know that I would have to reach 14. But there are many times in which I do want a loop to run a predetermined number of times. 5 times, 10 times, 1,000 times, whatever. When that's the case, then I really need 3 things. Some type of counting variable, a way to test that variable to see if we've gotten to that point yet, and a way to change or decrement that variable. Because I could count down, I can count up, whatever. But I basically need these 3 components. So let's say I want to sum the integers from 1 to 5. So I've actually sort of combined some things. I could do this differently, but I need to produce the integers from 1 to 5 and find out what their sum is. which also means I need the loop to run 5 times. So the way I implement it was this. I have a summing variable because I'm trying to produce a sum. My sum variable is initialized to 0. I start I at 1 because I'm summing these integers 1 to 5. And I said while I is less than 6, update the sum, update I, and when it's done, print out the sum, which is 15. Now, does it have to be this way? Not at all, but this is one way to do it. But let's talk about this part about the I less than 6, and let's look at some code. So I have something like this, and we're going to change this up a little bit. So let's have count equals 0, I is equal to 1, while I is less than 6. I plus equal 1, count plus equal 1. Remember, if you've seen my statements video, well then you know this is an alternate to count equal count plus 1. And then finally print the loop ran 5 times. So why do this? Why not just write this? That also runs 5 times. Well, that's perfectly fine, just like I also could do this. Wait, what was that before, actually? I was about to make a mistake, sorry. That runs. That's perfectly fine if this is what I want to do. Now the convention is when loops run a predetermined number of times, in most cases, you're going to start I at either 0 or 1 and then go less than the appropriate number. Could you do these other things? Sure. But like in this case, if I did this, because the convention is not to do this, somebody might look at this and think, well, why did he use 101? Is there something special going on here that I don't understand? It would actually be confusing to somebody. Whereas if I did this is actually the most common way. And I still get 5 times. So why is that? Well, when we get to lists, what we'll see is that when processing things in a list, depending on how we're using it, but in many cases, I will also need to use these numbers themselves, I. So it's not only keeping track of how many times the loop ran, but it's being used for some purpose. And that's actually what guides this. If I'd said, how many numbers are there from 101 to 105? Well, there's 5, right? 1, 2, 3, or 101, 102, 103, 104, 105. Now that makes sense, although now this statement should be changed to batch it. But when we process lists, we'll see that in many cases we'll need a variable that starts at 0, and if we want to do something 5 times, then we write less than the 5, as opposed to less than or equal to 4, which would be the last number we normally would have. That's the rationale. And when we get to lists, like I said, that will make more sense, but get used to doing that type of thing. But those alternatives I showed you, those are all fine because they accomplish the same thing. But just get used to that. All right? Let's talk about the for loop now. So the for loop can achieve the same results as the while loop, but it works differently. In Python, the for loop is what we call an iterator. So what we actually do is we give it a set of objects, and then what it's going to do is it's going to take the objects in order and repeat some process as long as there's still objects in the set. So let me show you what I mean by that. Now I might actually have to sort of jump ahead and show you what a list looks like, because that's, to me, the most obvious example. But let's say I had this right here. For, that's a variable name. So if I wanted, I could use zebra, although it would be kind of weird. But I could have used that here. It doesn't really matter. for I in, and let's give it something like this. Cat 14.6 38 colon, and then if I say print I, it's going to print cat, it's going to print 14.6, then it's going to print 38, because on the first iteration I is this. On the second iteration, I becomes this. On the third iteration, I becomes this. And once I run out of things, the loop stops. So let's see this particular example here, just to prove it to you, because it may seem kind of strange. There's a colon at the end. Cat 14.638. So could I have done other things? Sure. But it's iterating through. So notice I never had to check and see how long this was, or had I finally reached the final value of I, or whatever. I just becomes each of these values along the way. So this actually has lots of use, which is probably one of the reasons why for loops get, in my opinion, used more often than while loops in Python. So let's see how we could have done what we did from the while loop earlier though. So here I want to sum the integers, so I'm repeating this right here. I want to sum those integers from 1 to 5. And so I'll write this code. Sum equals I for I in range 1 to 6. Why 6 instead of 5? I'll explain that in a moment. Notice here's where I use I. So I'm going to use 1 because ranges don't give me the numbers from 1 to 5. So I'm going to add each of those to my sum and print the final sum. All right? So how does this work? So in the general form, range has this syntax. What it produces is a sequence of integers. So A is my starting integer. B is my stopping integer, except we keep going as long as we're less than that number. Less doesn't necessarily mean by 1. It just means less than that number. And then C is an optional step size. Now, if your step size is 1, like what I was using, then I can leave C out. So I could have written here 1, 6, 1, and it would work the same way. In fact, let's see that, just to prove it to you. And I'm just going to print I instead of producing the sum, just to show what numbers we get. And there's those 5 numbers. All right. Leave out the step size of 1. The same thing. If instead I'd said 2, so that means I go 1, 3, 5. 1, 3, 5. 20. 1. So what happened here? Well, the first number was 1, which is less than 6. The second number is 21, which is not less than 6, so it stopped. So that's how it works. Now, there's many times in which you just want to do something a certain number of times, like we did here. I want this to run 5 times, but here I also was using the value of I, so I did have to put in the 1. But if I said simply just do something 5 times, then I simply could just give it essentially B, the stopping number, and then what it would produce would be 0, 1, 2, ... down to B minus 1. So it's another reason to get used to that syntax for the while loop I described earlier. So I could have done this. So now we won't see 1, we'll actually start at 0. So this will run 6 times. So I go from 0 to 5, which is 6. While we're here, because I just thought of it, let me also point out that we're not restricted to integers in my while loop. So I could have done this. I is equal to 12.34 while I is less than 35.78. I plus equal 4.6. So you see I get that. 12.34, then I add 4.6 to it to get this. 35.34 is the last number less than this. I also can go the other direction if I want. So greater than 0. Or say greater than or equal to 0. Let's do that. And here I'll put minus. And let's make it something easier to follow with. I'll just make it 4, but I could use 4.6. Whoops, what happened there? Sorry. This is all right, so 12.34, subtract 4 from that is 8.34, 4.34, and this is essentially 0.34. And I could have used a minus, but then this actually needs to be correct, which I didn't have something that was correct, so this would be, say, minus 25. Right. It does that. So you have a lot of variety there, but the range function expects integers, right? So what about changing loop behavior? The vast majority of loops that we create will be what I just showed you, but there are times in which you want to prematurely break out of a loop or skip past all remaining statements in a loop. And for those, we can use the first thing I described as the break statement, and the next thing is continue. Now let me point out to you that some people will tell you you should never use either of these. I don't agree. Should you always use them? No. They can always be avoided. But the problem is that sometimes trying to avoid using one of these requires that I write some type of convoluted expression. And my expressions in my while loop could be complex just like they are for my if statement. Yeah, I can say while something is true and something else is true or something is not true. I can do stuff like that. So we can always write some kind of complex expression to keep the loop going. But if you never use these, then to me it's kind of like in English there's a rule that you shouldn't end a sentence in a preposition. But if you always try to speak that way, then sometimes you start to sound like Yoda from Star Wars. So I find that on some occasions, not many, but on some occasions, it's just easier to use one of these two statements. And the fact that these keep showing up in programming languages says I'm not the only person who thinks that. All right, so let's see an example how this works. So I have a loop here that's going to run 10 times. How do I know that? I starts at 0, keeps going while I is less than 10 in increments of 1. All right. Notice I do the incrementing here. That's another difference between a while loop and a for loop. I have control where I do the incrementing. So here, we never print 0. I actually print 1 to 10, except for 5. See, it goes 4 to 6. Because when I got to this point and said, well, if I was equal to 5, continue, what that means is I skip past the end of the body here and come back up, which is also one reason why this is here. If this had been down here, I would create an infinite loop. In fact, let me show you that. So we'll take this code right here. Let me move this over here so I can see what I'm typing. Right. So I think that's the same thing. One, two, three, four, skips 5, 6, 7, 8, 9, 10. Could I avoid that? Sure. The easy way to do it would be this. If I is not equal to 5, then print it. But there are situations where it's not that easy to avoid using it. Right? To show once again what I started to say was, why not just take this and put it down here? Right? Well, here's what's going to happen. So this happens quite often actually when people are writing loops. So what's going on? Well, I've created what's called an infinite loop. Right? It's trying to run, but the problem is because now I can't get past I equal 5. I can never get down here to 6, to 7, to 8. So 5 is always less than 10. So to stop this on Linux or Mac OS, I press Control C. See right here, the caret C, that's the Control C caret. That's how I stopped it. But that's one of the problems with this. All right. While we're here, let's see the break, what that does. One through 4. So what happened? When it hit the break, it said since the break was created in this loop, then break out of the loop prematurely. And one of the places you'll use that is when people deliberately create something that will always be true here. Then you obviously need some type of braking mechanism to stop the loop, right? So that would be one of the applications. But to show you over here, here's an example. So here I say while true, which obviously is always true. I prompt the user for a number. Now what's going on here? The input function in Python 3 and above will display this message to the user, and then they get what the user types in on the command line, but what input returns is a string. So even if the user types in what looks like a number, it's actually returned the string type. And so here I'm converting it to an int because I'm assuming that they're typing in, well, here I tell them an integer, so it needs to be an int anyway. But this converts it to an int, which then I can compare to 0. Because I tell them, as long as you're giving me numbers that are greater than or equal to 0, I'm going to keep going. But once the person types in a negative number, well, since that's less than 0, I'll break, and so I skip out here to print all done. And so you get this right here. All right? So typed in 3, printed 3, 0, printed 0, 99, printed 99. Negative 7. Negative 7 is less than 0, so I break, so I just print all done. And that's the basics of loops. Let's talk about the idea of a nested loop. Loops repeat processes, and sometimes the process that you wish to repeat is another loop. So let's say that what I want to create is this. I want 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right? So that's 3 times. And there it's 4 numbers. So how do I do that? Well, let's start with what's happening on each row or each line. Well, this is what happens, right? Because when I want to print, for the way we're printing, it doesn't print 1, 1, 1, and then 2, 2, 2, then 3, 3, 3, then 4, 4, 4. It prints 1, 2, 3, 4, then it goes to another line, prints 1, 2, 3, 4, then it goes to another line, then it prints 1, 2, 3, 4. So what's being repeated? This part right here. So let's see that in action. So 1. So 1, while I is less than 5, in steps of 1, print something. Now, the default for print is to insert a new line. So to suppress it, I'm going to add this. And let's see what happens. And so I need some spacing, but those are the numbers. So let's do... or we'll do this. All right, there's my 1, 2, 3, 4. Now, what if I want then to come the carriage return to bring my code down the next line? Well, the printf then goes here, or the print, excuse me. So this will print a new line. I get that right there. So there's one line. How do I do the others? Well, let's see what happens here. So remember the way my loop works is, so if I had something like this, if I said, I want something that runs 3 times, so I might say k equals 0, while k is less than 3, do something, and then k plus equal 1, right? This would repeat something 3 times. Well, what is do something? Do something is the code for printing 1, 2, 3, 4. So I'm going to take the loop that does this and put it at the D something position, which means it needs to be indented to match this logic. Let's see that. So this is what needs to happen for each line, right? So now we'll say k is equal to 0, while k is less than 3, k plus equal 1. And now, here's where the do something part goes. So I need all this to be indented. So just to make sure I don't mess it up, I'm going to indent it all at once using Vim. This is an example of what's called a regular expression. All right? So I just indented all of this. And now take this part and put it in that section. So let's do this. Start, do something. End, do something. Or start and stop would be the better match, right? Let's see if that works. It works. So what happens here? The code is processed top down. So k is 0. Is 0 less than 3? Yes. So now I is 1. Is 1 less than 5? Yes. So print 1, increment. Is 2 less than 5? Yes. Print. Is 3 less than 5? Yes. So this repeats. Eventually I is 5, so this breaks. So now I return to this level. I print the new line, add 1 to k, and go back up to the k loop, which is here. Is 1 less than 3? Yes. So now I start over. I is equal to 1. Is 1 less than 5? Yes. And repeat. And eventually k will be 3. And so this fails. And so I will get to this point right here. And that's how it works. So I'm repeating with k a process in which I'm repeatedly doing something, which is the I loop here. That's how that works. So if right now your head's hurting, that's normal. I find that many students struggle learning how to nest loops. But just think about what I said over here on my piece of paper. The k loop here runs 3 times. On every iteration, I want to do something. And that do something is another repeatable process. All right? So let's come back and look at this one more time. So what happens if I put a break or something in here? Well, what happens? Well, it depends on what level it's at. If the break is inside the I loop, it's I loop that breaks. So let's say I did this. If I equal 3, break. So I get 1 and 2. When I is equal to 3, then it breaks this loop. And actually this is the loop, sorry, this is the loop. It returns to this one where it increments k again. If the break had been at the k level, then that would be what breaks. So let's change this to something where it's easier for me to show you. Let's say 10. All right, so I'll just run 10's time. So now I take this loop right here. And what matters here is not necessarily this position, it's this level. And now I'm saying k, right? So now I'm at the level of the body of the k loop. And so instead of printing 10 times, it stopped. Well, we start at 0. So before I ever said k was equal to, k got to 3, which is technically on the 4th iteration. That's why we have 4 lines. So before it ever got to k is equal to 4, then it broke. And continue does something similar. If I put the continue inside here, this would be the loop that skips past the remaining statements. If I put it at this level for the K loop, this would be where the continue operates. So technically they could have some combination of the two. Each of them could have a break, each could have a continue, one could have one could have the other one, or whatever. But I probably myself wouldn't have a lot of situations where I'm going to have multiple breaks and multiple continues. They're not something you should be using all the time, and technically you can always avoid them. But that's the basics of loops. So let's sort of summarize, if you've seen my previous videos, where we're at. So in terms of summary, we've seen the basic programming constructs, right? So we have variables. Any program of any significance is going to have to store information, and for that we use variables. I can't imagine writing a program of any significance that doesn't also ask questions. So we have conditionals. And then finally, any program of any real significance will have to repeat processes. So we have loops. So these three things will show up in the vast majority of programs that you write. Can you avoid them? Sure, I can do things either the hard way or that don't really do anything that really matters. But if I really got some real work to do, I'm probably going to use some combination of these. Right? So how could you avoid these? Well, going back, if you've seen my introductory video, I ask you to, what if you need to repeat a process? So if I told you to print the integers from 1 to 5, this would be the way to do it. And since I'm using Vim, I got to cheat and just copy my lines. But if you're using an editor that doesn't let you easily cut and paste like that, it'd be a little harder, so I can do that. But what if I said, well, I didn't really mean 5, I meant 500, 1 to 500. Well, I certainly wouldn't want to do it this way, right? Isn't it just easier to say I is equal to 1, while I is less than or equal to 5 initially, print I, and then I plus equal 1. And you say, oh, well, I really meant 50 here. That sure was an easy fix versus adding 45 more print statements and having to cut and paste them and fix them. So you have to be competent at these fundamental ideas. They're not going away. You're going to learn other things, but these things here never go away. It's like arithmetic. You can learn calculus, you can learn linear algebra, you can learn statistics, but being able to add and subtract and multiply and divide numbers never goes away. You just use them in more complex ways. If you found videos like this helpful, please hit the subscribe button and let your friends know if you think they would be helped by these videos as well.